Uniform probability distribution is also called rectangular probability distribution. If you have fx as the probability density function for a continuous random variable x, then the area under fx from x equivalent to a and x equivalent to b gives you the probability for the interval. And we know finding the probability for this interval, you just need to integrate fx for the given interval. Okay, why is this called uniform distribution? You can see the connection between the graph and the distribution itself. Please take note that for uniform distribution, it will be an horizontal line like this. That is why it's called uniform distribution. And why is it called rectangular distribution? It is called rectangular distribution because you can see the area under the line is of a shape of a rectangular. Now let's look at the connection between the fx and the graph. In the question, the interval will be given in this form. And you know this interval can be written in this form where x is between a to b inclusive. And if you look at this, there's a connection between the interval and the function. So if you know the interval, you can form the function by yourself. And how's the function constructed? It is 1 over b minus a. Once you know the function fx is given as 1 over b minus a, representing the horizontal line that you have drawn for the interval between a to b. Let's look at example 1. Example 1, the probability density function is given as 0.2 when x is between 1 to 6. If you want, you can check out whether this is uniform distribution. If you calculate 1 over 6 minus 1, if you get 1 over 5, and that will give you 0.2. So you can say that this function is a uniform probability distribution. So if uniform probability distribution, you know the shape of the graph. It is uniform like this. The interval is 1 to 6 like this. And the fx is 0.2, which was calculated in this manner. Now let's calculate the probability when x is between 2 to 5. So I can choose to use area because it is a little bit faster than just finding the integration. So between 2 to 5, we are looking at this area. So this area will give you a width of 3 and the height of 0.2, which is shown here very clearly, and they'll give you 0.6. If you still want to do integration, you just integrate the fx between 2 to 5, and you should be able to get the same answer. Let's continue the same question. Now we are looking for the probability of x between 5 to 6. So if we want to use the area, then this is the area we are looking for. So the width will be 1 and the height will be 0.2. So width times the height 0.2, you will get 0.2 as the probability. And if you don't want to use area, then you can just use integration. That means you integrate 0.2 from 5 to 6, and you should be able to get the same answer. Okay, let's look at example 2. This question says the continuous random variable x has the probability density function as shown below. Okay, in this case, you can clearly see that it is uniform distribution. So therefore, you can connect the interval to the value of k. So how do we find a? The value of k, it is just 1 over 5 minus 1, which is 1 over 4, and that will give you 0.25. Next, look at part B. Part B is asking you to find the probability density function. So now you have to write it out very clearly. The fx is given as, I can choose to write as 1 over 4. X is between 1 to 5 and 0 elsewhere. Okay, now let's look at part C. Part C is asking you to find the probability of x less than 3. So if I want to do area, I'll just need to find the area 3 minus 1, which is the width, times the height, which is 1 over 4, and I will get 2 over 4, which is 1 over 2. Look at part D. Part D is asking you to find the probability between 2 to 5. So in this case, if I still want to do using area, then I will just have to do 5 minus 2 times 1 over 4, which is the height. So in this case, I will get 3 over 4 as the probability. Okay, let's continue with part E. Part E, you can see it is still the same graph as we have counted earlier. K is actually 1 over 4. So now how do I solve this question? You can see the question is a conditional probability. Conditional probability, therefore you have to find the probability of x between 2 to 5 first. So now using the graph, where is 2 to 5? If this is 2 and this is 5, this is the area we are looking at. So what we can find from 2 to 5, if we multiply the width, which is 3, times the height, 1 over 4, you will get 3 over 4 here. Okay, within the area, you must find the x less than 3. If x is less than 3, then we are looking at the area 3 here, and because it's conditional, it must be within 2 to 5, so it will be just this space. So if this is the space, then it will be P between 2 to 3 only. So 2 to 3, the width will be 1 times the height 1 over 4, and that will give you 1 over 4. So altogether the probability will be 1 over 3.